Video we will be discussing a problem from Leetcode, which is greatest sum divisible by 3. So basically problem says that given an array of numbers of integers, basically we are given an array of integers where each index has some value assigned to it, and we need to find the maximum possible sum of elements. We need to find the maximum possible sum of elements of the array such that it is divisible by 3. So the main key point is that it should be divisible by 3. So let's verify this first test case. So what is the problem trying to say? Okay, so basically this is our first test case that we will be discussing. So like for this test case, as we can see, if we include 3, 6, then we get some 9. Okay, 9 is completely divisible by 3, but still, is it the maximum one? No, obviously not. It is not the maximum one. We can include like 5 and 1 also. Now the sum becomes 3 plus 6, 9, 9 and 6. It is 15. So here the sum becomes 15. So obviously it is greater than 9. So yes, we are required to think like this only. But in this case, if we don't consider like 5, if we don't consider 5, we only consider 3, 6, 1 and 8. Now the sum becomes 9 and 9, 18. So yes, it becomes 18 now. So yes, this is the problem that we are required to solve. So basically the first approach that can come to our mind is like we can generate all subsets of like size 1. Of size 1 there will be like 3, 6, 5, 1. They're single sets. Okay, so like this only we are required to generate, we can generate all the subsets and then we can find sum of each subset. For example, if I consider like, let me clear this out. Okay, so like we consider this subset. Okay, basically here the sum will become 14. Okay, so if I consider this and this element, now the sum will become like 6, 5, 11 and 19. So like this we can generate all the subsets, but obviously if we will be going to do that, then our complexity will be increasing lot. Like it will go to 2 to the power n, as it will take 2 to the power n if n is the number of elements of the array. So basically 2 to the power n will be the complexity of generating all the subsets. And yes, after that, to calculate the sum of each subset, and the worst case complexity will be like n. So basically it is more on a higher side. What else can we do? Okay, so just as there is another question like target some subset of DP. It is good question. So we can try that also, to like we can generate the DP table, and for all the sums from 0 to like the maximum, like maximum will be in this case, for example 3 plus 6, 9, 14, 15 and 23. So basically yes, 23, and on this side it will be all these elements of the array. But yes, we can do that, and on each side as we find the sum, we can check that is it divisible by 3. So it is one of the ways you can think of. I will discuss this approach in another video. But in this video, basically why this approach cannot be proceeded with. For example, the constraints are high, like for each element is of the form like 10 raised to power 9 or 8. So but we can't generate that huge array, because as we know that we can at max go with 10 to the power 4 into 10 to the power 4 for a 2D array, basically, approximately. Basically this is approximation. So if the length of the array is 10 raised to power 4 and maximum length basically of the array is 10 raised to power 4, and any element is like 10 raised to power 4, then what issue we are facing, like 10 raised to power 4 of each index multiplied by basically 10 raised to power 4 indices. Basically it will come out to 10 raised to power 8. And since we know that 10 raised to power 8 will be the maximum sum, basically the worst case, so we can't generate 10 raised to power 8 columns and 10 raised to power 4 rows at the same time. So yes, that's why this approach is not possible. So what else can we do? Okay, so we will be discussing what else can be done. So yes, so I will be this is basically the DP table I will be defining. So here these are the indices. We will be traversing it from left to right, and the basically the meaning of each index is basically okay 0, 1 and 2. So here we will take the length 3. I'll tell you why. Okay, and we will be traversing it from left to right. Now here each index represents like this index, what will this index represent? Basically the maximum sum that is obtainable up till this index, which is when divide basically which when modulo with 3 gives the 0. And similarly this will define when the maximum sum possible up till this index when moduloed with basically when percentage, basically this sum percent maximum sum percent 3 is equal to 1. So it will store this, and this index will similarly store the maximum sum basically when moduloed with 3 gives a remainder 2. So the main idea about making this is because like we can think of, for example, if we join basically add the maximum sum which we are getting at 1 and which we are getting at 2, then we can think of like 2 plus 1 is coming out to 3. So this can add up to our required answer. So that's the thought process behind doing this. So let's do it and see within iterations what can be done. For example, I start with from here. Firstly I will consider 3. When I considered 3, I will check if 3 here now the sum is actually now 3. I will be checking if 3 is 3%, 3 3%, 3, what will it come out to be? It will come out to be 0. Okay, so now I know that I have to go to basically 0th row and check that which is maximum. Like I will choose the maximum between this 3, as the sum is 3, and already present value here. Already present value is obviously 0, so I will update it to 3. Now since no more possibilities are possible, so obviously these are left as it is. So basically this is the base condition of our DP. Okay, so now I will traverse for this, uh, do something for this index. Okay, so what I am doing is, now the sum will be, basically sum will be updated to, lastly it was 3, now it will become 3 plus 6, 9. Okay, so I will check if 9% 3 again, what will it come out to be? Equal to 0. I again know that I have to go to 0th index of this. Okay, so I will go to 0th index of this and now check if 9 versus already present value here, which is maximum, obviously 9. But yes, there is one more possibility. The one more possibility is, like, if we add 9 to this, will it also form, basically 9% this index, the value present at this index. When we add up to that, let's say it is x, it comes out to be x, then x% 3, will it be 0? If it is 0, basically whatever it is the value, we will go to this index. Whatever the value will come out to, we will go to this index and we will do a maximum, like, I'll try to explain, like, if x% comes y can obviously range from 0 to 2, and that is closed interval. So obviously, basically, we can go to any of these indices, and what we have to do, we have to update that index with what? Basically x versus the value present already on this index. Like, you will come up, you will be able to understand slowly when I will be iterating for more test cases. So let's do that first. Basically now I will do, like, if 9, here it will become 0 and 0. Now when I will do it for 5, okay, so 5, now the sum will be updated to 14. So I will do 14% 3. 14% 3, when I will do, it will come out to be basically 2. Now I have to go to second index. Second index, basically it is this index. Okay, so at this index I have to perform, I have to put 14 versus the value already present at this index, maximum of both these values, basically it is 14. So okay, I will keep 14 here. Now I will check 5, this 5 plus this value, what will it come out to be? It will come out to be basically 5. Okay, so 5% 3, what will it come? It is basically 2. So we will again check. Okay, 14, we will go to this index. When we will come to this index, it will check 14 versus 5, which is the maximum. It is obviously 14, so it will be 14 only. Now we will come to 9. We will come to 9. Okay, so now what we will be doing, when we will come to 9, we will again do the same thing. We started from this, then this, and then this. It will go up to in this fashion only, like this, this, this. for all of them. So when I will be doing it for 9, basically it is 5 plus 9, basically it is 14. Again the same sum, so obviously it will be 14 only, and we have to update it with previous either this previous max. Okay, so basically the previous max was 9. Okay, so unchanged. Now we will add 1. Now the total sum will become 15. Okay, so what will be doing now, we will be doing again 1 plus 9. Okay, so it is basically 10. 10% 3, it's 1. Okay, it's 1. Now what will I be doing is I will go to first index, and first index is here. Okay, so I am here. Now I will check the previous value versus 10, which is maximum. It is obviously 10, so I will be updating it to 10. Okay, so again I will be doing like now for this, I'll be checking 1 plus this, it will again come out to 1, and again we will go here, and now we will basically I'll do it 1% 3, it will come out to be 1 1, and again we will be going to this index, and now the competition will be between 10 versus 1, obviously 10 will win, so that's the case. And now we will come here, 1 plus 14, and it's 15, and 15% 3, 15% 3 is equal to 0, and we will go to now 0th index. Okay, 0th index, 0th index, and we will be updating it with 0 versus 15, it will come out to be 15. Okay, so this is the case. Now no cases left. Now we have to update this also. We have done all the cases like for first, second and third. Now this is left, and we will be updating it with previous max, which is 14. Again in this test case, what we'll be doing, we will be first considering 8. 8 plus 15, 8 plus 15 is 23. 23% 3, it will come out to be basically 2. Now we'll go to second index, basically this place. Okay, so we'll come out to this place, and we will be updating it with 0 versus 0 versus 23, it will be 23. And now we'll be go to 8 plus uh, 8 plus 10, it will come out to be 18. Okay, so 18. Now 18% 3 is equal to 0. We will go to 0th index, this index, and what we will be doing, 18 versus 0, which is bigger, 18, we will be updating it to 18. Now we will be going here, 8 plus 14, what will it come out to be, 22, and 22% 3, it will be 1. Now we'll be updating it to 22, and we will return this value, and if we see that yes, for this test case this is the answer. So now we will be coding this. So okay, so first let's make, I'll change the variable names. So I'll be creating a dp array, dp array 2d dp array of length n and basically 3. I'll initialize n as length. So basically I'll be creating a loop to iterate every index, and another loop for another loop for basically iterating the rows 0 1 2 which we had created. So basically it's j++, and here we will be initializing our base case if I equal to 0. Basically the base case is uh, this part. So we will be initializing it. If I is equal to 0, then what we will be doing is dp of I of j is equal to, not j, basically it will be j a of I, right? So basically a of I percent 3. Now it will automatically go till this column. Okay, so I'll do another step. Int index on which we have to go. Basically it is a of I percent 3. This is only for the base case, but from next cases we will be considering total sum plus ai. So keep this in mind. So basically it's index, and be doing this is equal to a of I. Easy enough. And one more thing we have to do. It is just for the simplicity, basically for better understanding. And a of I. Always remember that whatever percent we are doing, we have it will always come into comparison. Okay, so yes, this is it. Now else case is like this part, all this part on the right side of it, basically. So yes, if I'll again create index. Now here lies the thing. dp of I of j and previous row, like 6, we were adding 6. Now what, into which we have to add 6? We have to add 6 to first 3. I'll change the color so that it is better visible. We will first 6 to 3, then to here, and then here. We will add 6 to all of these and then check each index. So basically that is the case, yes. And what we will be doing is dp of I of index is equal to, we will be keeping maximum of what? dp of I of index versus dp of I minus 1 of j plus a of I. Okay, so here I did not put positive sign. And what else is possible? Yes, another possibility is that basically I of j is equal to, we have always like we had to update here 14 from the previous one. So yes, it is for that case that we did. So that is it, I guess. It should be working. Now we have to return dp of, basically what we have to return, dp of n minus 1 of 0. So let's check if it is right. Okay, so we have done some mistake here. Equal to, Why am I facing this issue? That index. Okay, so always keep brackets in mind. So yes, it is working all right. Let's try to submit this. So hope you were able to understand what I was trying to do. Like we can also print a DP table. It will give us more clarification. So let's also try to print our table. Okay, so yes, as we see, yes, we have mm, our table is being printed in a right way, like we thought of. So yes, so let's meet in the next problem and stay tuned, and don't forget to share, like, subscribe. Thank you.